Hello everyone, I am Likita Kivi studying in Sri Venkateshwara College of Engineering, Department of Electronics and Communication. Today's subject is Applied Physics and my topic is Fundamentals of Vector Calculus. Coming to what is vector calculus is also known as a vector analysis, deals with the differentiation and integration of vector field, especially in three-dimensional Euclidean space. Vector fields represents the distribution of a vector to each point in this subset of space. Concept of vector point function and vector differentiation. What is a vector point function? If to each point P of x, y, z of a region R in space, there is associated a unique vector f of P or f of x, y, z, then f is called a vector point function. The set of all points of the region R together with the set of all values of the function f constitute a vector field over R. Vector differentiation. The derivative of vector is found by differentiating each component of vector with respect to variable of interest. Suppose a vector R with components x, y and z defined in term of t, that is R is equal to x of t, y of t, z of t. R is equal to x of t, y of t and z of t. It is denoted by del. Divergence and curl of a vector field. What is divergence? The divergence is roughly a measure of a vector's field increase in the direction of its points. But more accurately, it is a measure of that field's tendency to converge towards or diverge from a point. Curl. The curl at a point is proportional to the on-axis torque that its tiny pinwheel would be subjected to if it were centered at that point. Gradient of scalar field directional derivative. What is a scalar field? A scalar field associates a scalar value like temperature of or pressure to every point in space represented mathematically as f of x, y, z. Directional derivative. The greatest rate of change for a scalar field with respect to position is represented by its gradient, which is always parallel to the field surface at that point. The gradient of a scalar field is also known as the directional derivative of a scalar field since it is always directed along the normal direction. Vector field. A vector field assigns a vector that includes both magnitude and direction to each point in space represented as f of x, y, z is equal to f of 1 into x, y, z, f2 into x, y, z and f3 into x, y, z. Line integral of vector field. On integration of the line integral of a vector field is the amount of work that force field does on a particular as it moves along a curve. Applications of line integrals. A line integral is used to calculate the mass of a wire and it helps to calculate the moment of inertia and center of mass of an area of wire. It is used in Ampere's law to compute the magnetic field around a conductor. Coming to Green's theorem. Green's theorem says that if you add up all the microscopic circulations inside C, that is the microscopic circulation in D, then that totally exactly the same as the microscopic circulation around C. Stokes theorem. The classical theorem of Stokes can be stated in one sentence. The integral of a vector field over a loop is equal to the surface integral of its curl over the enclosed surface. Integration from C f into dr is equal to double integration del into f dot rx into ry dx into dy. Finally, coming to the Gauss divergence theorem. The Gauss divergence theorem states that the vector's outward flux to a closed surface is equal to the volume integral of the divergence over the area within the surface. The sum of all sources subtracted by the sum of every sink will result in new net flow of an area. Integral from V del dot F into dv is equal to integration from dou V F dot dA.